Given A and B are similar matrices, then if PA is equal to 0, if and only if PB is equal to 0. That means if A satisfy a polynomial, if and only if B satisfy that same polynomial. In other words, that is both satisfy same polynomial. We need to prove this. Okay. Before proving this, given A is similar to B, implies there exists P such that B is equal to P inverse AP. P is invertible. Of course, then only we can talk about this inverse. Okay. First of all, we will see some observation. Let's do some observation before the proof. What is B square? We will use here the B. This is equal to B into B. This is equal to P inverse AP dot P inverse AP, and this product will be identity. This will be P inverse A square P. So one thing to observe is that the power we take here of D will become the power of A here. We have B is equal to P inverse AP. We get B square is equal to P inverse A square P. Similarly, by induction, B to the power K is equal to P inverse A to the power K into P. There is no issue in that. And similarly, if we just take alpha B, this will be equal to P inverse alpha A P, putting the value of B, and we can just take the inside. No issue in that. Now observe that, consider just B square plus B. This will be, we have calculated B square, it is simply P square and let A inside plus B from the definition is P inverse AP. Now note that we can just simply, this is equal to A square plus A into P. You simple open it, you will get this. There is no issue, just calculation. Okay, now again see here, there is a polynomial in B and the same exact polynomial is here of A in A, and just we are multiplied by P inverse and P on the both sides. So this observations tell us that if we take any polynomial okay, we have to use different notation. If we just take any polynomial, say Q B, then it will be equal to P inverse Q A P. This is what we observe from these results. This is not difficult to prove, simply proved by induction. Okay, now we get to the main question. If given QA is equal to 0, then what happen from this? QB will be P inverse QAP equal to P inverse 0P. This is equal to 0. So QA, any polynomial which satisfied by A implies that polynomial must be satisfied by B. Now we go other round. We assume that QB is equal to 0. Then what is QB? QB was P inverse QAP. This is equal to 0. Now we multiply by, we take this P inverse to here, we get QAP P is equal to 0. Now we take this P to here. Simply multiply both sides by P inverse. This will be QA is equal to 0. What we have got that if QB is equal to 0, this implies QA is equal to 0. Hence QA is equal to 0 if and only if QB is equal to 0. Hence proved. This is the result we are trying to prove. Both satisfy same polynomials. Here I use P, and in the proof I use Q because I have taken P 2 times, therefore I don't want to use it. Proof is done.